Thanks again. Very happy to be here to be part of one of the challenge statement for the BM Cycle 5. And my name is Jonathan, and I'm the sustainability lead for Pay United Corporation. So today our challenge statement will be about the robotic concrete slump testing and cube making. So a little bit about Pay United is that we have set ourselves some pretty ambitious goal, which is by 2050, we actually aspire to be a carbon neutral concrete company. And then how do we get there is through a series of digitalization and innovation. And we actually made it our purpose to actually decarbonize the world with concrete. And why concrete is also because cement is actually one of the hard to abate industry that's one of the major contributor to the carbon footprint emission around the world. So a little bit more about Pay United is that we are a Singapore homegrown company, and we have business presence not just in Singapore, but also in Malaysia and Vietnam as well. So a bit on the current situation about our challenge statement. The current process is actually very manual, which the intensive tasks will extend to mixing of concrete, filling molds, leveling, finishing the surface, and then follow by demolding and handling for sample. And I will go into deeper on what actually each of these component comprises. So the first problem that we have here is with the manual slump check. On the top left is actually the process on what is, the actual process on how a slump test is being conducted. And then on the bottom is where what are the acceptable and the not acceptable kind of slump result. I will play a short manual video on how the actual slump is being performed in one of our concrete batching facility. So first, concrete freshly batched from the central mixer will be discharged from the mixer truck. And then one of the worker will then push the wheelbarrow of concrete to a designated testing site. So this is where he will prepare all the slump equipment. First, he give a quick mix. And then therein, he pour in the first layer. So after which, they will temp for at least 25 times. This is to compact the concrete. And then followed by the second layer. And then repeat the same tamping process again. And then the third and final layer, where he will tamp again. Then he will invert the slump cone, where he will place the shovel on top of the cone range, and then with a measuring tape, measuring the slump range. So this is how they get the eventual range, which is what you see which is the acceptable range under the section 2. So next we move on to the concrete cube test. So the process are largely similar. First, you prepare also 3 layers, and then you tamp out to remove any air and then to compact the concrete. So it's actually just go on and on with the similar process. And at the end, with labeling to indicate when and what type of concrete is this. So basically, you get a gist of it. And the entire process is very manual. And what are the problems that we face with the manual processing? First is with accuracy and consistency. As you can see, uh, the worker one and worker two can have different variation, even though they are following the same set of standard and all this. And then also the layers, the three different type of layer, also there will be inconsistency no matter how accurate you can structure it. And then also in terms of manual, they are also very time consuming. And then they will become a bottleneck in project where where the rapid testing are required. And thirdly, it is very labor intensive. Imagine doing the same whole thing, mixing things for more than 100 or even few hundred times a day. And then this will all lead to fatigue and then injuries. And last but not least, the problem with scalability. With the more concrete site that we are supplying to, there will be more requirement for such tests. And then what are the stakeholders involved? I mean, of course, the construction companies, they will be very interested in having accurate testing, as this will ensure quality and compliance. And then the workers, it will be directly affected by these changes to the work process and also potential job structuring. And of course, the regulatory bodies will also be concerned with the quality and safety standards. And last but not least, the project managers and engineers on site, they will require reliable data for such decision making. So moving on. So why is it important that we are, looking at and tackling this problem? First is the quality assurance. So if we can automate the entire process, it can improve the consistency and also the accuracy of this test, which lead to a higher construction quality. Secondly, it will increase our efficiency and productivity because you can significantly reduce the time needed for testing. And third, it will improve the safety and ergonomics. So you can see our manual labor can be reduced, and then that will decrease their chances of injuries. And last but not least, it can also boost innovation and competitiveness by adopting automation. And what are some of the requirements that Pay United is looking for? First, of course, is accuracy and consistency, as with all testing. So the system must be able to deliver uniform result that will comply with industry standards. Second, it should be easy to use and should be operable with minimal specialized training. Third, adaptability. It should be also capable of handling different concrete mixes and specifications. And then speed. Ideally, it should be faster than what we are currently having now. And last but not least, also very crucial, is safety. It should be automatically able to halt any operation to prevent further accidents upon detection of any intrusion. And then these are just some of the good to have that we would like to see. It can be in the form of robotic arms that is precise in handling the materials and mold. The incorporation of sensors and AI. This will help in assessing and adjusting the consistency of concrete mix. And third, the ability to log and analyze test results for future quality control. And last but not least, it will be designed for easy maintenance and also high reliability in terms of concrete batching plant solution where it's exposed to high dust condition. And what are some of the operational consideration that I hope will help solution providers is that this solution should fit in seamlessly with the current project management and testing framework. And secondly, training should be provided and also ongoing technical support. And third is cost effectiveness. The initial setup cost and ROI must align with financial objective, meaning to say, it's not something that is really out of the world. And third, it must have the ability to scale up to handle larger volume or even deploy to multiple sites. And what Penn United Corporation is prepared to support is in terms of this following area. First, we will provide the necessary equipment and materials. This could be the slump and cube testing equipment, and then the materials needed, such as the concrete and then the cube molds required for the project. And then we will also offer our technical expertise that is relevant to this project, offer our expertise in material science, engineering, and also how our guidance and how we can troubleshoot, whatever the problem that we may encounter. And last but not least, we will provide access to pay another facilities such as our testing lab, our batching plant, and also to customer site if there's a need to scale up. So that's all I have. Thank you.
Thank you, Jonathan. If you have a question, put it onto the chat, and we'll channel that question. We'll get to your questions very shortly. Jonathan, just a couple of things, maybe just to start. So it seems like whether it's the cube or the slump test, basically it's roughly the same steps with the tamping, the 3 layers, so on and so forth, but just in different mold shapes. Is that a fair characterization of these two tasks?
Yes, you are largely correct, except for the slump. At the end of the whole tamping process and the leveling, there's a need to remove the slump for the measurement of the slump reading. Whereas for the concrete cube, it will largely remain the mold and then let it set for further testing.
Okay, thank you. And a couple more questions. In terms of solution providers giving you, making a submission to you, if somebody makes a submission for just a slump test but not the cube test or the other direction, is that okay for you, or you're really hoping that one solution actually must cover both?
So in my room here, I have Mr. Chen Hong, Pay United Associate Head for the technical department. So maybe you'd like to take on the.
Maybe actually we prefer that one robotic arm can do the both job. So that means can do the slump test. After slump test, they can do the cube making. Yeah, 2 in 1.
Okay.
So just now, also somebody maybe asked how many samples we are doing. So typically, if we are in our plants, 200 over cubes will be made. In some project site, even more cubes, a few hundred cubes are required. For the slump test, I think typically 50 to 100 per day.
And that is covering just one production site. At Pay United alone, we have more than 15 all over the island, just to give the landscape.
Okay. Can you repeat those numbers again, because I feel that that's important?
Number of cube, maybe a few hundred, 300, around 250 to 300.
Okay.
Number of slump tests is about 100 per day.
Okay. By your estimation, how much time or manpower is being used to do each of these in a day at one production site?
Normally we have 2 or 3 manpower cube, or we call it cube man. I think it's 24 hours. If the plant open 24 hours, they are working for 12 hours shift. So 3 by 3, so roughly 6 person needed.
Okay. Okay, thank you. Any more questions for anyone? Any other questions from anyone? Just a
The
follow-up
average
question.
of 250 to 300 cube is for one batching facility. So at Penn United, we have estimate about 15 facilities.
Okay. So that's a lot of cubes each day.
Yep, that's correct.
Okay.
Are you able to see very clearly? Okay, sure. Thanks. Okay, my name is Glenn. I'm a Dimeled Private Limited. In short, what we actually do, we actually light up buildings, make them look beautiful and look nice for our owners. That is what we principally do. And yeah, so this is some of the projects that we have been involved in. Okay, so we do turnkey solutions. We can do from design, engineering to system integration and all the way to the implementation stage. These are some of the, just to quickly run through, these are just some of the projects that we have been involved in. Yeah. Okay, this is another smaller scale project for interior lighting. So besides doing system integration for facade lighting solutions, Dimeled also owns MBA Enterprise. MBA Enterprise is actually an electrical contracting company that we do installation of electrical systems. Right. So this is just a brief introduction of what our company does. So we install anything from electrical systems to fire protection systems to building management systems, PA systems, anything that involves cabling, yeah, is something that we are able to do. So these are some of the projects that we have done. So we have done full installs for different type of buildings, even for large hospital compounds like Institute of Mental Health. So these are just some of the projects that we have been involved in. Okay, so we are actually BCA certified for MUO4, MUO5, and MUO6. Okay, so just a short introduction, end of the short introduction. So I'm just going to run through very briefly on the proposed problem that we wish to solve on our site. Okay, so this is just based on a very basic observation and also a rough survey around our peers of the same industry. As you know that there are all sorts of services in the building that is consisting usage of M&E services, and we estimate around maybe 20 to 30% of building costs actually goes to M&E services. Okay, so if you look at M&E services, it consists of it's actually the scope is actually quite wide. So it's not just merely just mechanical and electrical, even security systems, PA systems, fire protection, building management, lift systems, even IT systems. You know, we all use cables and we run them all around the building, especially for new build. You don't want the cables to be seen. They're mainly concealed in walls, or they will be installed on cable trays and trunkings. Okay, it's just the article that I found on the 24th June 2023 by Ashprop Property. The average cost of Singapore construction, just a ballpark. So they actually put it at US dollar 3,307. Okay, and the gross floor area of some of the buildings in Singapore, at least the major ones that we see in the above example, you can see things ranging from 80 over SQM all the way to 20 over. Some there are even 100 overs. So I'm just giving us an idea of the gross floor area of most buildings that we can find around. And certain things to consider is that if you look at the construction cost of 307 per SQM, which we are looking at about 4,000 over Sing dollars. So if you look at a building with 50,000 square meter building, that will cost as high as 223 million. right? So M&E services, if we look at our previous observation of about 30%, that will account to about 67 million worth in the building cost of a building. And looking at Singapore's direction towards a smart future, we will expect buildings to be getting a lot more complex, a lot more complicated, with a lot more services that will be running around our buildings. Yeah, which requires more cables. And one of the things that we want to consider is that one of the principal activity for M&E installations is actually cable pulling. Right. Okay, some of the objectives, problems that we see on site that we want to solve is that cable pulling is like most construction activities, it is actually very labor intensive. So we have a few workers pulling the cable from one end to the other, and the cables can stretch all the way from like 30, 50 meters, all the way to kilometers worth of cables used, depending on the size of the project. So we also want to minimize exposure especially for areas where there is work at height involved. We want to minimize the exposure by being able to streamline the process to make it much shorter, so that they minimize the exposure, or if even possible, is that we have a device that is able to reach the height without having to use any lifting equipment. For personnel lifting equipment, yeah, so as to minimize the exposure to risk and accidents. As we know, fall from height is one of the highest, most common fatal accidents in Singapore. And having such a device, we also envision, hope that is able to work on certain alteration projects for A&A projects that require certain replacement of the cable that is already concealed in the building walls, and we want to prevent, or rather reduce, at least to minimize the amount of hacking works that has to be done on the walls. And so to reduce that, it would be good to have a robotic device that is able to run through the cables, and we just replace them as it is, and we don't need to touch like the original conduit systems. And also certain sites, commercial sites especially, they have very complex containment system or environment. For example, this is one of my sites that we have this floorboard system, and you can see that the conduit, the red conduit pipe, is actually being obstructed by a lot of other services. So these are things that we can find pretty commonly in many of our sites, and these are actually hard to reach. And in order to replace or do any amendments, to all these conduit systems, it will require us quite a bit of work, to either remove it or to install it somewhere else where it will be quite troublesome for the project team. We estimate that we spend at least 30% of our time in our activity on cable pulling. And so cable pulling, if we look at our previous survey of 65 million of construction costs, 30% of that is around 19.5 million. And if we say that contractors, electrical contractors can save up to 50% of that amount, we can roughly save about 9.8 million maybe per building cost. And it might be even more, depending on the scale of the M&E that is being required. As we see more smart technology, we might have even more cabling involved. And so out of this, we can say that for 50,000 square meter building, we will have almost about 4.3, or maybe say even more, 5% of total construction. So we are talking about quite a substantial amount of savings, on the part of construction costs. Okay, so some of the proposal that we are looking at will be a cable pulling robot. So traditionally, how cables are being installed is that we have a fish tape, some call it the wire rope, to pull through a certain containment, and then once that pilot wire goes through that containment, we will pull the rest of the wire through. So that is how traditionally cables are being installed. But however, as manual as these processes are, sometimes we might encounter certain areas where the conduit system or trunking system where the cable is unable to go through. So this is one of the problems that we face, especially for like A&A projects. And if we have a robotic arm, robotic device, we'll be able to pull through that wire through complicated conduit systems without much of a hassle. And this can actually save time and resources. There's some of the key requirements that we key considerations for requirement of the product is that it should be able to reduce the time taken to pull cable by 50%. It should be resilient enough to travel through different types of containment systems. Example would be conduit pipes, cable trays, and cable trunkings. And it should be able to be controlled by a certain smart device. And it should have a method of recovery should the device get stuck deep into the containment. Okay, what we can provide, we have storage facilities for you to do your prototyping and testing. We have actual project sites that we can do actual trial runs on actual sites to see if this solution is practical to be used on site. And we can support with our labor for end user trials. Our labor force will be able to support in terms of bringing this equipment for testing, and we will provide the materials that is required, for example, which is the cables and containment systems for the testing. Further funding or collaboration details we can discuss further should we find any shortlisted candidates. So how does this actually align to our company objective? Of course, we are from a consumer point of view, it actually increases our quality, our speed of working, and it reduces our cost, construction costs, as we discussed earlier. And of course, as a business perspective, we are also looking to use this as potential as a distributor or a reseller as a product. I mean, if this is something that we cannot find anywhere else in the world and it's something that we can develop in Singapore, definitely there is a worldwide market potential for such a solution. Okay, so that comes to the end of my presentation. Thank you.
Thank you, Glenn. Questions from the floor? Please type your questions into the chat box. Whilst we're waiting, maybe a question from me, Glenn. What do you think are figuratively and literally the main obstacles of deploying such a robotic solution?
I would say maybe the difficulty might be having a robot to be able to travel through different types of surfaces because there are different types of material for containment and also different profiles. We have got trunking, which is roughly square in rectangular in profile, and conduit pipes, which is circular. And also in terms of the strength of the robot, it should be able to withstand or rather pull through a tension of maybe kilometers or a few hundred meters of cable, in one go. And we're talking about like maybe not just one cable, but maybe a few strands, depending on the circuit that we are trying to run.
Okay. If we are to start somewhere, what do you think is a reasonable proof of concept for you? Because, I appreciate there's a lot of complexity and there's a lot of different types of systems, for example, or complicated situations. What do you think is the basic test that you like to see, the proof of concept?
At least perhaps it can pull through a pipe also, in a straight line at least. Yeah, and at least be able to move without being obstructed, and without being stuck at a certain point. Yeah, and able to navigate through at least. Yeah.
Okay.
Oh, the typical dimension of a conduit, we have 20 mm. That is the diameter. We have 25 mm, and some has up to 32. But the typical ones is 20 and 25 mm. Yes, that's right. The robot should travel inside the internal of the conduit to pull the wire through it. Then after that, you have the worker to receive it on the other end. No, it's a 20 mm diameter. Yeah, if you talk about times something, that will depend on the length. Yeah, it could be like 30 meters. Yeah, that's right. Yeah, it could be 30 meters. It could be 100 meters. Yeah, in one go. Then maybe after that, you will continue to another side of the circuit. That's correct. 20, 25, and 32. That's my correct answer then.
Just to maybe probe a little bit in terms of that question about traveling inside the conduit. There's no way this could be outside the conduit with some sort of magnetic linkage with the inside.
I wouldn't say that it's not possible. Yeah, I wouldn't say it's not possible, but I'm wondering if there will be more challenge if there's a metal pipe versus a PVC pipe type. Yeah. I guess I'll probably leave that question to the more technical solution provider, but out of my mind, that would be my answer. Yeah.
Okay, thank you. Any other questions? Please type into the chat box. In terms of just one more question from me. In terms of operating this, does it need to be autonomous, or could you have an operator?
Ideally, there should be an operator. I mean, if it's relatively a straight line, I would say no issues for it being automated. Maybe we can do a 2.0 version 2 of the product that is able to have a bit of intelligence to it. But if you want to do like maybe the version 1, yeah, maybe not so ambitious first, but perhaps something that you can just manually use a smart devices, smartphone app or something that you can kind of control where the remote control, yeah, has to control where the robot will go. Yeah, I think that would be good enough.
Okay, all right. Thank you. Last call for questions from the floor. Anyone with questions? Just as a reminder, we will share the recording of this session. Please look out for our emails. We will share the decks as well so that you can have more details compared to what the challenge statements are as they are being published on the website. Any further questions? Otherwise, we'll close the session.